My name is Mark Maddox. I work in the marketing department for Tasco. With me is Diane and Jeremy, who's also in the marketing department, and I've got a little bit of background also in equipment. And I'm just got a short presentation today on why or what's happening in aluminum. Aluminum seems to be a very big topic, especially for the Ford people. And we want to talk about what's happening, a little history. I'm not going to go into how to do actual repairs or anything like that, but I will touch on the equipment you're going to need and some of the other things. I'm going to talk fast because I'm going to do 30 minutes. I know you all are on a lunch break and I want to be fast, but afterwards, if you want to ask me questions, I'll be more than happy to answer what I can. Okay? We're going to break down aluminum repair. Obviously, we steal our stuff. Go ahead and hit me, Jeremy. A little bit of history about aluminum in vehicles. Very early on, aluminum was the predominant metal in vehicles. The Model T hood was made out of aluminum, and the 1925 Pierce Arrow was all aluminum. And the reason aluminum was popular back then was, number one, it was cheap. And number two, you got to think about the manufacturing process. Before World War I, there wasn't an industrialized stamping process and everything for steel. So aluminum was really a softer metal. It was easy for them to hand form because cars were handmade back in them days. You remember, right? I know you. I can pick on you a little. So prior to World War I, automobiles used half of all aluminum produced in the world. Okay, and after World War I, and our manufacturing processes became more industrialized with the stamping processes and the metals, steel became more prevalent and aluminum fell to the wayside. In 1960, there was 54 pounds of aluminum in your typical vehicle. In 2012, there's 342 pounds. And it's projected that by 2025, there'll be 550 pounds of aluminum per vehicle. And that's just aluminum. That's not any of the high-strength steels that we're seeing or any other lighter substrates. Okay, why are we seeing more aluminum? Well, the main reason is weight. And the new CAFE standards, does everybody understand what the CAFE standards, that's the requirements for miles per gallon. The president, they had a standard that was averaged across the manufacturer's entire line. It had to average 39 miles per gallon from trucks to cars. They had to average that. Well, the president changed it, and he actually has a chart for different size vehicles. But basically, it's that cars have to be over 46 miles per gallon by 2025. And trucks will have to be over 30 miles per gallon. Now, when the manufacturers heard that, they obviously got to start making plans in their business. How are they going to meet this requirement? And a rule of thumb in engineering is that a reduction of 10% in the weight of the vehicle will produce an 8% savings in fuel mileage. So that's the whole premise that these engineers are working with and the automobile manufacturers are working with, is reducing the weight of the vehicle to get to the mile per gallon they have to get. So you're going to need new metals to meet these standards, and that's why I think we're already seeing boron, advanced high-strength steel, trip, and all the different kinds of metals. You guys, have everybody been seeing those? And differently, we're even seeing more aluminum. So right now, we're going to be talking a little bit more about aluminum. Okay, so why are they choosing aluminum? Well, aluminum's strong. Aluminum alloy, aluminum by itself, pure aluminum is only like 7 pounds, and I don't know what an MPa is, but it's the pounds of force to bend. And pure aluminum is very soft. But when you do alloys, by mixing in different metals and different items, different chemicals, you produce aluminum alloys. And they become 200 to 600 megapascals, I believe is what that is. And that's almost as strong, except for the strongest high-strength steels. That's as strong as most of the high-strength steels. The very highest strength steels go up to 800. So per pound, aluminum is 2 to 3 times stronger than steel. So that's their thought process of reducing the weight. They're going to be able to make thinner panels or panels that are lighter and still have the same engineering strength requirements that they need. Aluminum absorbs energy 2 times better than steel. What does that mean? Well, that means that you're going to be starting to see a lot of aluminum in your crush zones. So if it absorbs energy in an accident, it's going to crumple the crush zone easier if it's made out of aluminum. And it's not going to transfer energy throughout the vehicle. So that's why you're going to start to see a lot more aluminum in your front ends and in your crush zones. And I'll show you a picture of that here in a minute. Now, what are the differences in working with aluminum? Okay, aluminum does not have a memory. So that means how many times you have a dent in a panel and you pop it, it pops back out and goes back to where it was, right? That's how this whole PDR thing is working. Aluminum does not have a memory. Once it gets into a crash condition, it stays there. It's in a new position. It does not remember the original shape. So you're going to have to work it back to the original shape. Aluminum gets harder when damaged or worked. That's called work hardening. So every time aluminum crushes or you got to work it, it's going to get stiffer. So that eventually means that if you repair an aluminum piece enough times, the original function of a crush zone is going to go away because it's going to become harder and more brittle, and you're going to start seeing cracks. That's why a lot of the manufacturers, if they have an aluminum piece that's cracked, they're going to want you to replace it. Aluminum needs heat to be worked. You got to heat aluminum to be worked, and it's not just hitting it with a blowtorch like you do when you're doing a frame repair. Okay, you're going to have to hit it between 400 degrees and 570. And you have to be in that range. 400 degrees is where it's going to start moving. 570 degrees. If you go over 570 degrees, you will change the structure of the metal, and it will become permanently soft, and you've ruined the panel. So how do you do that? Well, there's a variety of ways that you do that. One is that they have these crayons that you can mark the panel with, and you've got two different crayons. You got a 400 degree, you got a 570. You draw the marks on there, and if the crayon starts to melt on 400, you start working. It melts on 570, you take the heat off. You can also use a digital thermometer. So it's very important to stay inside your heat range on these panels. That's one thing that's different. Dissimilar metal corrosion. When aluminum and steel combine, they will corrode. It's just a simple fact. So if you use a hammer that's been used on steel on an aluminum panel, you're going to take those micro bits of steel and embed them in the aluminum, and that panel's going to corrode. It's just a chemical fact. That's why you're going to see some of the things about tools and everything we're going to talk about having different areas. So I know I've worked on aircraft for quite a few years, and one of the things when we worked on aircraft, if you had a steel bolt in an aluminum piece, you always put sacrificial washers underneath them. So the washers would corrode. You replace the washers, not the whole piece, because you're going to get galvanic corrosion. By the way, corrosion on aluminum looks like white dust. I don't know if anybody knows that, but it looks like white dust. Training is very important because you're going to have to learn some new habits. I'm just briefly touching on some of these things. So going through the ICAR training is going to be a very important step to make sure you understand how to properly do this and safely do this. Okay, where are we going? Well, aluminum's been in European and high-end vehicles for a long time. I know the F-150 has an aluminum hood, right? It's had one for years, and we're starting to see more and more aluminum and different metals, and we're going to see more and more of it coming up. We all know that 2015 Ford F-150 is going to be all aluminum. And has anybody else heard about the 2018-19 GMC truck? Okay, the article that I read actually said the GM guy says, I'm waiting to see what comes out on the 15 Ford to see what they did right, and we're going to take it and apply it here. Because they're under the same restrictions of trying to get a truck to 30 miles a gallon. That's what they're trying to do. This is a picture from NADA in New Orleans. And this was the cutout vehicle that they brought, and I really wish I'd have taken my own pictures. I didn't realize how important this thing was when I was standing there. I wish I'd have taken my own pictures close up so I could show you a lot of the different things that I saw on this vehicle. One of the things is your bed sides. There's rivets all over this vehicle. Everything is riveted on or glued on, okay? Or riveted and glued. The whole bed side is riveted on with special aluminum rivets of a special hardness, and you got to use a special rivet gun to put them in, of course, okay? We have a nice video of that rivet gun. That rivet gun is really cool, but it's a little pricey. You'll see that the B-pillar, everything in this is aluminum. You notice that you got your crush zones are made, and this is riveted right here. So those pieces are made to crush, drill out the rivets, and replace them. The vehicle is designed to be modular to help make the repair of the damage easier. There's large cast pieces on the bottom. You can replace the floor plan. There's just a lot. It's all riveted and glued. It's riveted and glued on the roof panel. So this truck is a modular design. It can be. There's two different ways to replace to fix this. You can weld, or you can replace with rivets. We'll be posting this up on our website also. So if you want to get a better look at this, you can blow it up and look at it. I can't hardly see it. Let's go to the next one. Okay, what equipment is needed? Okay, and I'm going to talk about the Ford program specifically. Okay, because Ford is what we're dealing with here. And I'm going to tell you what the Ford dealers require of their people. Now, you're going to tell me, I've been working on aluminum for years and I've never done that. That's fine. I'm not telling you what you have to do. I'm telling you what's recommended by ICAR and what's recommended by Ford for their program. Now, you know what, I think I'm missing a slide, but that's okay. Ford estimates that 30% of their dealerships have body shops. And as of right now, they have about 850 dealerships that have applied for training and to do aluminum repair. They have about 450 independent shops that have applied to do the training to become Ford certified through the Ford program. For dealerships that don't have body shops, they will contact an independent shop that they refer all their work to, and they will certify the independent shop through the Ford program. There's pluses and minuses of the Ford program. That's something I can talk to you all in individual places if you want to know more about, but there's good points and bad points about it. But they do require you to buy all the equipment from Ford, correct? And and there's a lot of training and there's a lot of stuff to it. But if you want to be certified Ford repair, and I'm sure GM's going to have a similar program, that's what you're going to be looking at. One of the first things that they're going to ask you to do is to have a separate area. You're going to have to, we talked about dissimilar metal corrosion. You start grinding on an aluminum panel, and you start throwing aluminum shavings all over your shop, or you grind steel and you're throwing it all over your aluminum, you're going to have dissimilar metal corrosion, and you're going to have an issue. Okay, so they want a separate area. Curtains, separate building. It doesn't have to be vented. It just got to be. Doesn't have to have a roof on it, but you can go to any extent that you want to keep it clean. It needs to be a clean and aluminum specific area to be done. Next one. Well, we got. I should have checked this better. So now we got a picture of the welder. Go ahead to the next one, Jeremy. Okay, we're one off on our pictures to our slides. Okay, sorry about that. Okay, a pulse MIG welder. Ford's recommending the pulse MIG welder, such as, by some chance we happen to carry these, the ProSpot SP5. The pulse MIG, and again, there's a video of this welding. It shoots. It's got more power, and it pulses the weld compared to a regular MIG. It's a very nice welder, but it gets a lot of power right to the point and hits it and tacks it and makes a really nice weld. You're going to have separate tools, okay? And there's different. Everybody's carrying these tools, by the way, not just the ProSpot line that we carry, but there's a variety out there. But you want a workbench with separate tools, hammers, dollies, files. Most of the workbenches come with the thermometer you're going to need. It comes with the aluminum dent puller. It comes with this one has a bench on it that you can use, and you can see here on this bar here, that's actually a bar that you can put across the dent. It's got the claws that come in and pulls you heat it up and it pulls the dent out. And I have a nice video on that also. Go ahead, Jeremy. Okay, we just talked about that. Go to the next one. The rivet gun. $8,000. Now, from my point of view, since I don't have to buy one, it's really cool. It takes a special rivet. Okay, it's a special rivet, a special thickness, special type of rivet. It's a self-piercing rivet. This model, you load it up. It's like a single-shot gun. You load it up. You put it on the panel. You squeeze the trigger. It drills the hole. Inserts the rivet. Squeezes the rivet. Cuts the rivet, and you're done. It's all automatic. It's boom, boom, boom. It's pretty slick. But for $8,000, it should be. But you're going to have this type of aluminum gun to repair these Ford vehicles. You're going to have something like this. And this is what Ford is requiring. There has not been an alternative announced by anybody yet. Okay, next one, Jeremy. The other thing that they're going to, when aluminum and steel dust combine, it can create a thermobaric, I believe, explosion. Okay? you can have kind of like everybody know, like that corn silo. I'm from up in Kentucky and Indiana. You know, the corn silos, the dust, it'll blow up. That's what'll happen when you mix aluminum and steel dust together. So what Ford is requiring from a safety standpoint is it's called a wet mix air filtration unit. There's only one company that makes them. What it does, you can't use a shop vac, but it sucks all the aluminum dust in, wets it into a slurry, and then you can dispose of the slurry. And it's just regular waste, but it encapsulates the dust in water, and therefore it won't mix with steel and become explosive. That thing runs about $12,000. Yeah. So now you're seeing where, when you buy the basic equipment to become Ford certified, it's at least $50,000. Okay, go ahead, Jeremy. Up here, just so you all know, I put all my sources here, and we'll make all this available to you. And these are all the places where I researched, and plus some of the training that I've gotten at different places. Okay, I just wanted to give you all just a brief overview of what's happening. Are there any questions? Thank you for your time.